Hey guys, welcome to another video. In this video, we're going to talk about what is RAG and we will do some programming to understand how it works in code. So RAG stands for Retrieval Augmentation Generation. It is a prompting technique which solves various problems in LLMs. There's various limitations LLMs have like hallucinations, context awareness, and also LLMs are trained with previous data. They don't have the current information. So this is why we use RAG to solve these kind of problems. So as I mentioned, RAG is a prompting technique where we introduce more information in the prompts by retrieving from the database. So let's have an example like how is the Indian flag look like? So explain me that. So in this prompt, we will go and then vectorize this prompt. There will be a vector database. I already explained about the vector database. I'll leave the link in the description. When we found, okay, there's a similar information available about the Indian flag, how it looks like, it retrieve the information and add it into the prompt and then do the forward pass in the LLMs. And the LLM have more information. LLMs are already expert in writing, but they lack in facts. So now they have facts, so they can use these facts to make their writing process and generate the outputs. So that's basically how RAG works. Now let's see with the code how it actually works. Hey guys, so let's see how this works in code, and so let's jump into the code directly. Here I'm defining various imports. So some of the important imports are FAS, FAISS, which help us to do the similarity search within the data set. And then we have UVCon, which we're going to use to define the server, create a server. So I'm using GPT models. It requires OpenAPI key, so I'm retrieving the OpenAPI key from the environment variable, and then we have I'm creating an application, a fast API application. Next we have device. Device is basically going to use when we define the model for generating the embeddings. So I'm using in the Mac, so it will going to be MPS else CPU. You can also define CUDA if you have a CUDA device. So here we have model. So I'm not using here any GPT model to create the embeddings. I'm just using a normal language model because I think it will be much faster and relevant to the use case, which is the simplest examples. Then we have putting the data from the Hugging Face, so using the AGNews. So let me show you how this data set look like. So here we have various number of available samples, and then we have a function embed documents, which takes the text as a list of str and returns np.ntarray, which is an embeddings. So here I'm using this model which I have defined, sentence transformer, and then this will actually encode all the text, and then this is basically embeddings, and then I'm going to return that thing, right? And calling this function here by providing the documents, which is the text, all the text in the HNews, but it's here we have only 1,000 samples in the training set, so we are not using all the data sets. And then we are creating an index, and that index I'm going to put all the embeddings in there, so we can actually retrieve the information based on similarity search, which we are going to do with our prompt. We are creating index with phase and phase index flat L2, and then dimensions, just using .shape method to generate the dimension, to get the dimensions. And then here I'm using L2 distance for similarity search. So L2 distance is an algorithm which we're going to use to compare the two vectors, and then based on how they similar are, we're going to retrieve, and then we are just moving all our embeddings to this index. Next we have another function, generate answer with GPT-4, which basically returns the which basically do the generation from the GPT-4 model. And here it takes context. Context is basically the facts and informations from the database you have retrieved, and the question is basically the prompt which we're going to initialize when we call this API. And here we're defining client using OpenAI, and then using a client we're creating a chat, and then in that chat we are using this model, GPT-4 mini model, and then providing context and questions in the messages, right, and then returning this answer. So another function, the final function we have in this, is the retrieve and generate answer, which wraps all the things. First, it actually creates the embeddings of the prompt, the question, using this index.search function, which takes an embedding. So we are providing this query embedding, and then this embedding going to actually do the similarity from the whole database, and when there's a similar information available, it's going to retrieve. The second argument we have is k equals to 3. It is we can provide an integer value, which is like get the top 3 relevant documents. If we want to provide 10, then it will provide, like, it will going to retrieve top 10 documents. So 3 is something like typical we use in vector database, and then relevant docs will going to actually concatenate all the 3 results, and then in the end we have generate answer with GPT-4, which we are providing the context and question here, and then it will going to return the answer. So that was all for the RAG. That's it, like how you define RAG, and then we are creating a post API, and then creating a server. So that's it. That is the whole code for the RAG. This is the most simplest use case. Obviously, when you create large applications with RAG, you definitely have like more sophisticated architecture and code base. So you will have like a vector database in the cloud, and then you're retrieving information from there, and then you using various models, like let's suppose Llama, Claude, and different ChatGPT APIs. So basically this is very simple examples to actually show you how RAG works, and how we can actually define a data set and then retrieve the information from that, and where we can like put that information into the prompt of the GPT, and then it will provide the answer based on that. So here we have another script which we're going to test.py, which we are going to use to test this API. So it looks like I've already tested this, but let's again test this and show you how it works. Test.py, and then we have this probably answer. So in the question, let's see what is the question. So does rat can become drug addicted? The answer is yes, the rats can become drug addicts. Studies have shown that they have exhibit a compulsive drive for drugs like cocaine, similar to human once they are addicted. So let's see where this information is coming from, and is it very similar to what we have? Is there any information in the database, and is it correct? So we're going to actually investigate those things. So this is the data set, and I'm going to actually do the search here, rats. So here you can see like studies find rats can get hooked on drugs, rats can become drug addicted. So the sentences we have and like the information, it's kind of very similar, the output is. So you can see like that's why like we use RAG to actually provide the facts, and then the ChatGPT and like any LLM figures out based on our prompt how to present that information. So that is basically the RAG, retrieval augmentation generation. I hope you guys understood, and if you like this video, please like it and subscribe to the channel, and thank you guys for watching this video. See you next time.